In this video, I want to show you how we convert a point in the XY plane to polar coordinate and vice versa. For this purpose, consider point X and Y. The point P has a specific X value and a specific Y value. So we show it by P, X, and Y. Now, if you consider a line, straight line between origin and point P and call it R, you see that here we have a right triangle. And then there is an angle between x-axis and this line. Let's call it theta. Now, instead of point with coordinate x and y, I can say this point has coordinate and in the polar axis with r and theta, with a specific r and a specific angle, which is theta. So how we can convert from Cartesian to polar and from polar to the Cartesian? What is the relation between r, x, and y? Because this is the right triangle, based on Pythagorean theorem, you know that r squared it's equals to x squared plus y squared. So in this way, if we have x and y, we can calculate r squared. Then, what we know about theta? Because we have a right triangle here, and this angle is theta, we can calculate sine of theta and cosine of theta. You know that sine of theta is this angle divided by r, and cosine of theta is this angle divided by r. So sine theta equals y divided by r, and cosine of theta is x divided by r. From sine of theta, you can calculate that y is r sine of theta, and from the equation of cosine, you can understand that x is r times cosine of theta. So these two equations tell you if you have r and theta, then you can calculate y and x. How you can calculate theta? If you divide equation of sine with equation of cosine, you know that sine of theta divided by cosine of theta equals to tangent of theta. From the right hand side, you have y over r divided by x over r. So it's equals to y over x. So we found that tangent of theta it's equals to y over x. So if you have x and y and you are looking for r and theta, based on r squared equals x squared plus y squared, you can calculate r, and based on division of y and x, you can calculate tangent of theta. And if you have polar coordinate r and theta and you are looking for x and y, simply plug in this formula. X is r cosine of theta and y is r sine of theta. Now let's do some example together. Consider point 1 and pi over 4. As you see, it's in the polar coordinate. We have r and theta, and we are looking for x and y. So based on r and theta, how we can calculate x and y? As I said, x is r cosine of theta and y is r sine of theta. So by plugging r and theta in the formula, you can find x and y. R is 1 times cosine of pi over 4. Cosine of pi over 4 is the square root of 2 half. So it's the square root of 2 half. And y is 1 times sine of pi over 4. Sine of pi over 4 again is the square root of 2 half. So the answer is the square root of 2 half. So 0.1 and pi over 4 in the Cartesian coordinate is the square root of 2 half and square root of 2 half. If you look at x and y, you see these two are equals to each other. Now, let me show you the point on the x and y axis. This is the xy plane, and if here is the square root of 2 half and here is the square root of 2 half, then the point is here. Because x and y are equals to each other, actually the point is on the line x equals y, right? This is line x equals y. And you know that the angle here is pi over 4 because y equals x divide the first and third quadrant to two equals angle, right? So it divides pi half to two same angle. So pi over 4 here, pi over 4 here. And as you see, the angle is pi over 4. And then the r here, it's equals to 1. That comes from the x squared plus y squared squared. Now let's see one more example. Consider point -1 and negative pi over 6. Now we are looking for x and y. Again, x is r cosine of theta and y is r sine of theta. R here is -1 and theta is negative pi over 6. We know that cosine of pi over 6 is square root of 3 half. Then how about cosine of negative pi over 6? For this purpose, consider the unit circle. Here is pi over 6 and negative pi over 6 is in the fourth quadrant. You know that cosine of pi over 6, this amount is positive. And also cosine of negative pi over 6 is this amount. So again is positive. So cosine of pi over 6 and cosine of negative pi over 6 are equals to each other. Actually, cosine of alpha and cosine of negative alpha are equals to each other. So cosine of negative pi over 6 also is the square root of 3 half. So we have -1 times square root of 3 half. So it's negative square root of 3 half. Then to calculate y, we have r times sine of negative pi over 6. What we know about sine of pi over 6 and sine of negative pi over 6? Sine of pi over 6 is positive 1 half. But sine of negative pi over 6 is negative of sine of pi over 6. So it's negative 1 half. So we have negative 1 times negative 1/2, it's positive 1/2. So the point negative 1 and negative pi over 6, it's equals to the point, actually it convert to negative square root of 3/2 and 1/2. Now you may think that why x is negative and y is positive, but negative pi over 6 is in the fourth quadrant. In the fourth quadrant, x is positive and y is negative. So it's not equals to this. Here, x is negative, y is positive. Let me explain why when we have x negative and y is positive and it should be in the second quadrant, why here r and theta it's negative, and specifically theta is negative pi over 6, which is in the fourth quadrant. Actually, the point is in the second quadrant. So it's somewhere here. This is the point with negative x and positive y. Now, if I choose the radius, this one as radius. If I choose theta in the positive direction, this theta actually it's equals to 5 pi over 6. And r is positive. But here we have negative pi over 6. Negative pi over 6 is the opposite direction in the fourth quadrant. This is negative pi over 6. The movement is in this direction. But r is negative 1. If the point was in the fourth quadrant, then the polar coordinate was negative pi over 6 and positive 1. But right now it says the angle is negative pi over 6, so we are on this ray, but instead of positive r, choose negative r, and negative r it's in this direction. So this one it's negative 1 and negative pi over 6, but I can read it as positive 1 and 5 pi over 6. So again, this point is positive r and 5 pi over 6, or negative pi over 6 and negative 1, because positive 1 for negative pi over 6 is here. This is positive 1 for this angle, and this is negative 1. And for the angle 5 pi over 6, positive r is here, negative r is this direction. Now let's convert from Cartesian to polar. Consider the point negative 4 and 4. So here I have x and y, and I want to convert it to p of r and theta. How we can solve this problem? To find r and theta based on x and y value, we know that r squared is x squared plus y squared. So r squared is a square of negative 4 plus a square of positive 4. So it's 16 plus 16 or 32. So r is positive and negative square root of 32, or 4 times the square root of 2. Now you may think that why we have negative and positive r. In the previous example, you saw that r can be positive or negative. Actually, the direction says that this r is positive or negative based on theta and the direction that we choose. But definitely radius always is a positive amount. Then we need to calculate theta. To calculate theta based on x and y, we know that the formula is tangent of theta, it's y divided by x. Y here is 4 and x is -4. So it's -1. So tangent is negative and shows us the angle can be in the second and fourth quadrant, because between x and y, one of them is negative, the other one is positive. Based on x and y, you see that x is negative and y is positive, so we are in the second quadrant. So what is the angle? If tangent of theta was +1, then you know that theta is pi/4, right? But here is -1 and we know that it is in the second quadrant. So for this question, theta actually it's equals to pi minus pi/4 or 3 pi/4. We can think about the angle in opposite direction. So if we do not consider x and y and think about it that it's in the second quadrant, then another angle with -1 for the tangent is 2 pi minus pi/4 or 7 pi/4. Now you see that there are two r values and two different theta. Because the point is in the second quadrant, 3 pi/4 is this angle and it's in the second quadrant. So I can write it as 4 square root of 2 and angle 3 pi/4, or you can consider this angle 7 pi/4. R for angle 7 pi/4 is here, so here is -r. I can write it as -4 square root of 2 and 7 pi/4. So the point -4 and 4 in the polar coordinate can be written as 4 square root of 2 and 3 pi/4, or -4 square root of 2 and 7 pi/4. That's all about converting from Cartesian to polar and from polar to Cartesian. I hope these explanations were helpful for you.